Diffraction Part 2. We will look at the second objective. Let's try to analyze a single slit diffraction. We have got a diagram here for the single slit diffraction. We can see that there is a single slit of width A, and when light passes through this single slit, we get a pattern on the screen which looks like this. And to be specific, it's a red light which we are passing through the slit, and we can see that there is a central bright maximum which is flanked by other bright maximums. We can also see that the graph which shows the intensity of the light for the central bright fringe, it is the highest, the intensity is the highest because you can see that it's the brightest. And as we move away from the center, the brightness goes on decreasing, and you can see the peak is also decreasing. A few more things which we want to see. The distance of the screen, this is our screen on which we see this pattern. The distance of the screen from the slit is represented by capital L, and theta is the angle of diffraction. So the width of the single slit here is of the order of the wavelength. So that's the condition for having diffraction. So we don't get diffraction always for light waves. If you want to get the diffraction for light waves, the single slit which we have used, the width of that single slit should be of the order of the wavelength of the light which we are passing through it. Okay. The next condition which we see here is L greater than A. What is L? L is the distance of the screen from the slit, and A is the slit width. Okay, and the intensity is the function of angle. So if we increase the angle, we can see that the intensity is decreasing. So let me show it on the screen. So let's say that if you want to get the intensity at this point, we can see that the angle is getting greater in size. So more the angle, less the intensity. Let's check the features of the pattern formed in diffraction. Again, we have got the same diagram which we used before, and we have got the pattern which is shown here. So we are going to use the word fringes to define the pattern. So these bright spots and the dark spots which we see, they are called as fringes. So here this is a bright fringe. Okay, and we also can see there are dark fringes which are being formed. So it's a pattern of bright, dark fringes which we see on the screen. So we want to check out a few things here. We want to see how these dark and bright fringes are positioned, and also compare the width of the central maximum with the width of the other bright fringes. Before that, we can also see that we have got the condition for destructive interference. And if you remember, we said that we get the bright fringes because of the constructive interference. And we get the dark fringes because of the destructive interference. So the condition for the destructive interference is sine theta is equal to m lambda over A, where lambda is the wavelength and A is the width of the slit, and m is plus minus 1 or plus minus 2 or plus minus 3, and so on and so forth. So that's why we can see that we are labeling the fringes as y1 corresponding to m equal to 1. So this one is for m equal to 1. This one is for m equal to minus 1 or negative 1, and so on for the other fringes. Now, as we said before, we want to check out the following. position of the dark and bright fringe, we can say they are alternating. You have got a center bright fringe, then there's a dark, and then there's a bright, and so on and so forth. Also, the width of the central maximum is twice the width of the other maximums or other bright fringes. So if you see, we are using the word fringes and maximas and constructive and destructive interference. So remember, they all are indicating the same thing. The fringes are also defined by maxima or minima. So if I have bright fringe, I will be calling it as a maxima or maximum. Okay. And if I have dark fringes, I will be calling it as minima. Okay. You can also see how they are located using the formula. We can see that y1, negative y1, the value for sine theta is negative y over a, because m is equal to negative 1. And that's how we can get for the others also.